it seems as if it's best. So yeah, if we look at the following, we said we are dealing with more than one term on the numerator. Can you see that? And then even on our denominator, we're dealing with what, with more than one term. So I think that one is clear. Now, just like before, nothing has changed. We're going to split our question into the left-hand side, and then we're also going to split it on the right-hand side. And then if we're going to split it like that, I've been thinking about this to say, is it necessary for us to change the term? Now, it won't be necessary for us to change the term. For example, if they say, leave your answer as a single trigonometric ratio. So if you write something like this is no longer a single trigonometric ratio. If you write sine square x all over the cos squared of x, this is no longer a single trigonometric ratio. So there are instances whereby they will tell you to say, leave your answer as a single trigonometric ratio, then you will leave your answer as 10. If that's what they said. Otherwise, I would say to my learners, if you see 10, change 10. If you see 10, change it. Unless they say leave your answer into a single trigonometric ratio. Are we good then? Okay. The other thing that I said yesterday was to say, if you are dealing with fractions, and then you are dealing with more than one term, I said we should come and change this division line. Remember that? And then instead of writing this division line this way, we're going to use the division line that we've used in earlier grades, which is this one. Okay? I want to change that statement. Allow me to change the statement. I think we should change this division line to this division line only if there's a 10 in our numerator or in our denominator. The reason why we change it is because 10 is going to give us its own numerator and its own denominator. So if we see a 10, then we're going to change it. Otherwise, if there's no 10, there's no need for you to do that. Does it make sense now? So it's true that we are going to change the division line and use the division line of lower grades. But I'm saying, based on the questions that we are going to do now, it seems not to be necessary for us to change this one. Not to say that it's going to make that much of a difference. It's just that it takes a long process, and then we still come back to exactly the same thing. So we are going to check, and then check if we have a 10 here. If we have a 10, we change it. If we don't have a 10, we go to the next step. What is going to be our next step? Our next step will be to factorize. So you factorize your numerator, and then you also try to factorize your what? Now, we have two terms here. Is there anything common between these two terms here? Okay, what seems to be common then?
Cos x.
So if we take cos x as common, what are we going to remain with here? If we take cos x, left with 1 here, minus cos squared x, cos squared x, close bracket. All over. Then we can go to our denominator.
Yes.
What seems to be common in our denominator? This is term number 1, this is term number 2. So we take cos x. If we take cos x, what are we going to remain with? It's 1 minus
Sine
squared x. Okay?
Yes.
Now, from here on, we can clearly see that we have cos x multiplied by this whole bracket. Okay? And then we also have cos x multiplied by this whole bracket. But before we do that, what is this? What is this thing here? 1 minus cos squared. What is it?
Sine squared x is an identity.
It's an identity.
Yes.
So we come and say we are going to write that. And then what is this here?
Identity.
It's also an identity.
Yes.
So we have cos x all over cos x. Now, if we change this one, 1 minus cos squared x, what is that?
Sine squared x.
So we're going to have multiplied by the sine squared x. All over 1 minus sine squared x is what?
Cos squared x.
Cos squared x. Clearly from here, everyone can see that we have one term on the numerator, we have one term on the denominator. So what can we say from here? We can say cos is going to divide what? Cos. So when cos divide cos, what are we going to remain with here?
Sine squared
Sine squared
over cos squared x.
squared x. Is this thing and this thing the same?
Yes.
Therefore, we can say our left-hand side is equal to our 1 hour. Yes,
Right hand side, yeah, give example, Lily.
like S10.
Yeah, I said.
And then you went on to change this thing and say sine square of theta. And then when you went on to say, okay, instead of leaving your answer here, you ended up leaving your answer as the tan square of x. Yeah, and I was saying, in fact, I'm still trying to check which one is better, but because I'm teaching learners to say every time when you see a tan changing, I think it's best if we change the 10. But there will be instances whereby they ask you to leave your answer as a single trigonometric ratio, which means your answer will have to be to stop here.
Okay, that makes sense.
Yes.
Let us with one trigonometric ratio. One trigonometric ratio.
Yeah, it's simple. Yeah.
So then let's say for the acceleration like one trigonometric ratio.
So you're saying we should leave it as one trigonometric ratio instead of them saying.
Yeah.
Okay, I think let's adopt that. What they are proposing is that so every time, you know, we're not going to change the 10 if 10 is one trigonometric ratio. Like what we are trying to say is that if I have 1 minus 10 squared x, this is not one trigonometric ratio, it's 2 times again. But if I find myself in a situation whereby I have just tan theta, I'm going to leave tan theta, I'm not going to change it. So that's what we accept again. And then from here, we say we are going to come and do the following as a classwork now. Do number 1 and then do number 8. Now, as a hint here, guys, if you find yourself in a situation whereby you are dealing with 2 sets of fractions, here you are dealing with 1 set of fraction. I want you to notice that here. You are dealing with 1 set of fraction again. Mark allocation. Okay, we'll come back to that point. Let's explain this. If you find yourself in a situation whereby you have 2 sets of fractions, you are going to make them to be 1, to be something like this here. Then you can factorize and do whatever. How do you make them to be 1? You find an LCD as a hint.